We're talking to Dr. Sasha Wilmoth of the University of Melbourne. Hey, Sasha.
Hi, thanks for having me. Great to be here.
I wanted to ask you about a headline that took me a weirdly long time to process, but your background isn't in processing. So what do you do normally?
So I work in language documentation, particularly on Australian Aboriginal languages, and I've mostly worked on Pinjara, which is a language in Central Australia. And I have done some processing research with some psycholinguist colleagues, but it's not my main area of research.
Oh, so
Yeah.
that's why you got in touch on this Twitter thread that I saw.
Yeah, because I had that same experience of reading that sentence and it was so jarring. My brain was like, "Dut, dut, dut, dut," like every word was just took a while to process. So I was like, what is going on here?
Well, that's what I liked about this. And we're
Yeah.
going to get to the sentence, but I'm really interested in this because I love thinking about how language in some ways takes the form it does because of demands on processing. We try to make things easier on our listeners. And also, we've been talking with Dr. Mark Ellison about attention. We don't like to pay constant close attention to someone,
Mhm.
so we pay close enough attention. And meanwhile, we're making tons of predictions about what's going to happen so that if there's a mismatch, we can go back and ask. We do a lot of shallow processing. Have I got that about right?
Yeah, that's exactly right. So we want to make it easier on our listener, but we also have this sometimes competing pressure to make it easy for ourselves. So we want to expend as little effort as possible. But if we just say "bleh" for everything, then that's not going to be easy for our audience. But at the same time, if we make things super, super clear and explicit for our audience, that requires a lot of effort from us. So there's these two competing pressures.
It
Yeah.
requires a lot of effort from us, but also getting things into words very precisely takes a lot of time. Like Stephen Levinson says, encoding is slow, but decoding is fast. So our
Mm.
listener's going to get bored. So there's that kind of pressure too.
Yeah, exactly. And the thing about close attention that Mark was saying, although I haven't listened to that conversation yet. Um, there's sort of this principle which people have called the uniform information density principle. So
Oh,
we want to keep the amount of information like fairly constant and easy on our listener. So we're not packing too much into one sentence, which is what was so weird about that headline.
okay. Well, let's get to the headline
Yeah,
then. Would you read that for me? It's from
sure.
space.com.
So it is potatoes are better than human blood for making space concrete bricks, scientists say. It's
I,
hard to even read out.
I know I'm tripping over it. And I also love how it's a completely bonkers headline, but then it ends, comma, scientists
Scientists say.
say, in a completely normal fashion. So why did this tie us up so badly, do you think?
So the reason is most of the words in this sentence, even though it's like grammatically very normal sentence, the words are very unpredictable. So it's very uncommon to start a word with potatoes. But
It
then,
is? Okay.
well,
All right. It's not very common. I haven't done it for a while.
yeah, exactly. But not unheard of. But if you start a word with potatoes, then the chances of the second word being are
Hmm.
is, pretty high.
Pretty
There could be
good.
some other things there, but, pretty likely to be are.
Hmm.
And then, better than, that's not too crazy. But then it's when we get to almost every single other word, they just are so unpredictable, we can't anticipate what's coming next.
Human blood.
Yeah, I actually don't even know what the story is about.
I
Didn't
don't
even
either,
look
and
into it. Yeah.
I'm not able to guess.
Yeah. I prefer not knowing, I think.
Yeah, I had so many questions I got lost. I mean, what is a space brick? How do you make one out of a potato, and why would you? And then blood?
And then
What?
why are you comparing potatoes and human blood? Like, that's your two options?
So we've talked about garden path sentences before, where
Yeah.
the syntax kind of messes you up. For example, the prime number few. What? The prime number? Oh, this wasn't prime number. This was the prime. Those in their prime. Number
Oh, okay. Yeah.
few, right? So
Yeah.
prime sounded like it was going to be an adjective, but it wasn't. It was a noun, and everything went wrong there. But this isn't a garden path sentence at all. It's a straightforward sentence.
It's grammatically, syntactically completely straightforward. Yeah. So it's just
Okay.
the semantics and the unpredictable words that are tripping us up.
Okay, well, let's talk about the surprisingness then, because you showed a graph. I'm just looking at it now, and I'm going to slap this up on the show notes for this episode. So, what I'm seeing here is a very bumpy graph. It's got I guess if it's up more, then it's the surprisingness, and every stop on this bus trip that this graph is a word. Have I got that right?
Yeah, exactly, pretty much. So this is a graph of surprisal, which is basically surprisingness. And you can quantify that using information theoretic techniques. So this is like a whole sort of field of mathematics, and linguists can apply that to language as well. So we can actually tell what are the chances of each word occurring. And then if it's a very uncommon one that's very surprising, we say that that has more information content in that word.
Okay, so we're not
Yep.
measuring any kind of physiological response in me for this bumpy chart. We're
No.
looking at how likely a word is to occur at all, and then maybe also in context?
Yeah, so this is about how likely a word is to occur based on the word that came before it.
Okay.
And so this is based on corpus data, so huge amounts of text in English, and then language models can sort of quantify what are the chances of each word following another word.
So on the chart, it starts out really high. You said that it splits up potatoes. It made potato the first token and the second token?
Yeah, I'm not sure why that was. I think that's just some weird quirk of the algorithm or the data that they're using.
Okay, so
Yeah.
potato, as you say, was the most surprising word. It's way up there on the chart,
Yes.
and
Yeah.
that's a weird way to start a sentence. So, okay, that's the surprisingness. Then it goes way down for are better than.
Yep. So you can see better is the first little spike up, and
Mhm.
then it goes way down because then is almost redundant.
Better
Well, not
than.
quite. Yeah,
I
it's
hear better than all the time.
exactly. Yeah.
Then I get a slightly more surprising. Now it goes up for human blood.
Yeah.
I guess human blood is just very vivid. It's something that you weren't expecting that, especially in the context of potatoes.
Yeah, exactly.
Okay, and then four goes down again.
Goes down and then up for
Making.
making, just not that
A little
surprising.
a
Yeah,
little
a
bit.
little bit.
And then space concrete bricks. There it goes.
Yeah. So
Up.
that's like 3 highly surprising words in a row. You cannot predict what's coming next after each of those.
Scientists say. And then you see that scientists say is way down again
Yeah,
because that's a
exactly.
totally normal thing. And then the
Yeah.
last one is the end.
So actually there's I think the comma counts as its own token in the way
Oh,
that it's
comma as a
yeah,
token
yeah.
naturally. Okay. Okay, well, I think we've explained the surprisingness. It takes a lot of weird twists and turns, and that's all in the semantics.
Mm.
You mentioned that this was an entropic sentence. What does that mean?
Yeah, so I maybe should have been a bit more precise and said that, the sentence overall has a high information content or high surprisal overall, but I could say, like, at each point, there's a high conditional entropy. So entropy
Oh.
sort of meaning uncertainty.
Okay.
So at each point, we sort of don't know what's coming next. And overall, it's very surprising.
So the more surprising it is, the higher the entropy. Is that right?
Yeah, so surprisal is a measure of the information in a single event, and entropy is a measure of the uncertainty across a distribution of events.
Is that like how easy it would be for me to replace a word if it went missing? Does that have anything to do with entropy? This is something I understand very poorly.
What do you mean if a word went missing?
If there was some noise or a car horn went off and I couldn't hear a word that you said, how
Ah,
likely would I
okay.
be? Like if somebody honked the horn at than in better than, I could get that back. I could
Yeah,
get that back. But if it was concrete, I'd miss it. I
yeah.
wouldn't. So does that have anything to do with the entropy?
Yeah, it absolutely does. That's a great thing to maybe explain. So, this comes from a sort of model of communication that Claude Shannon came up with in the 1940s when he was working on cryptography during the war effort. And so, he was interested in how do you compress information as much as possible.
Mhm.
And the model of communication is that you have some sender. I have a message, I have something I want to say to you, and I encode it into some signal. That could be speech, it could be Morse code or smoke signals or anything, but some sort of signal where we've agreed on what the code is. And then you, as the receiver, have to decode it, and it crosses some. That signal might be through a noisy channel. So there might be a car driving past or honking or something like that. And then you have to be able to decode it and narrow down the message to my one intended message. So The reason that we have lots of redundancy in human language is sort of because we're always in a noisy channel. There might be something else interfering with the message, as well as the processing costs. We can't be constantly as efficient as possible. And I guess it comes from the genre of a headline, right, compared to normal discourse.
Where things are left
Yeah,
out,
exactly. Because,
different words are used.
yeah, if you're thinking of compressing information, a headline is actually just a compressed form of a story. So
So the
it's
format is also
really,
playing a role.
yeah, I think that's also what's going on. So it's trying to cut out all the unnecessary and redundant information and just get down to what's the core, most informative things that we can pack into a short sentence for a headline. Whereas if you were discussing that in a conversation, you'd pad it out across multiple sentences and introduce each idea to give your audience some time to process what's going on.
Okay.
Yeah.
So this sentence took us a long time to process. So I'm going to read the sentence one more time. Potatoes are better than human blood for making space concrete bricks, comma, scientists say. And this took us a long time because it's got really unpredictable words. The words in the sentence are surprising. And then it's also in the format of a headline where things are left out, and that causes a bit of hang up as well.
Yeah, I would say that's a good summary.
Fantastic. Well, Sasha, I'm really grateful that you came up on Twitter and responded that way because now I feel like I understand a bit more about language processing and time.
Great. I'm happy to help. Thanks.
Sasha Wilmoth at the University of Melbourne. How can people find out what you're doing? Do you want people to find you?
Yeah, so I am on Twitter, and then I also have a website where I post publications and stuff. So on Twitter, I'm just my name, Sasha Wilmoth, and my website is just sashawilmoth.com. And I'm on Google Scholar and all the usual sites as well.
We will have links up on the show notes for this episode. Sasha, thanks so much for hanging out with me and explaining stuff.
Thanks so much, Daniel.